Okay, so we are on page 8 in your chapter 10, part 1 packet. We're going to go over the difference between a minimum value and a maximum value in terms of quadratic functions. So, a parabola, as you know, can face upward. In that case, the vertex is a minimum point, or it can face downward, in which case the vertex is a maximum point. So what's the difference between a minimum point and a minimum value? Well, the minimum value is the y value of the vertex. So the vertex itself is the minimum point. The y value is the minimum value. So you have a minimum value with an upward facing parabola. You have a maximum value with a downward facing parabola. And the minimum value is looking for the y value. Okay? So now on this page, we're just going to go over some other vocab. And when you have your quadratic function in standard form, it opens up when a is positive and it opens down when a is negative. So when a is negative, it's a reflection. It's narrower or it stretches when the absolute value of a is greater than 1. And it's wider or it shrinks when the absolute value of a is in between 0 and 1. The axis of symmetry is a line, and the formula is x equals negative b over 2a. And the x value of the vertex is negative b over 2a. And to get the y value, you plug in that x value into the function. And when we let this x equals 0 and this x equals 0, you end up with y equals c. So 0c is your y-intercept. Okay, so now I'd like you to turn to page 12. So, let's see. This is page 12. Okay, so on page 12, we go over maximum and minimum values. So again, when a is positive and it faces upward, you have a minimum value, or the vertex is the minimum point. When it's upside down because a is negative and reflecting, you have a maximum value. Okay, so be aware of when you have a minimum, when you have a maximum. Now, the problems you're going to be given, it says, tell whether the function has a minimum or maximum. Well, that's just another way of saying, is this a reflection or not? And since a is positive here, it's going to face upward and you're going to have a minimum value. And the minimum value is the y value of your vertex. So here it says, because a is 5 and 5 is greater than 0, the parabola opens up and the function has a minimum value. To find the minimum value, find the vertex, and the minimum value is the y value of the vertex. So to find the vertex, first we find the axis of symmetry, and we use this formula to find the axis of symmetry. So b is negative 20. So negative b is 20. And 2a is 2 times 5, which is 10. So x equals 2 is your axis of symmetry. So once you know your axis of symmetry, you substitute 2 into your formula. And 2 squared is 4. 5 times 4 is 20. 20 minus 40 is negative 20. Negative 20 plus 17 is negative 3. So the minimum value of this function is negative 3. The minimum point is the vertex, and the vertex is 2, negative 3. Okay, So this is asking you whether or not there's a minimum value or a maximum value. So first you determine if it opens up or down, and then you know the minimum value or maximum value is the y value of the vertex. So go ahead and do checkpoint number 3 on your own. Stop this video, and when you're done, start it again. Okay, so if you're back, that means you have completed number 3. So let's go over number 3. So for number 3, the first thing I'm going to do is say, okay, this is opening downward, therefore that's a maximum value. How do I get the maximum value? Well, first I find the vertex. How do I find the vertex? Well, first I find the axis of symmetry. How do I get the axis of symmetry? It's x equals negative b over 2a. So it's negative 6 over 2 times negative 1/2, which is negative 1. So this is 6. So my axis of symmetry is x equals 6. So how do I get the vertex? I find f of 6. So I do 6 squared plus 6 times 6 plus 8. So f of 6 becomes 6 squared is 36. Half of 36 is 18. So this is negative 18 plus 36 plus 8. So f of 6 equals 26, which means my vertex is 626, and my y value of my vertex is my, in this case, maximum value. So my maximum value is 26. Okay, and that's the end of this video.